Okay, I'm going to talk to you about some of the sample problems from your section 1. So we'll work through some of these. It may not be exactly the way your problems are listed as it regenerates, and it could be in a different order, but it should be somewhat the same as your homework, or very helpful to you as you go through your homework. Okay, so here's the sample one, just a couple of kind of concept questions about types of equations. So it says a blank is an equation that's satisfied by every number. So whenever you solve it, you get a special case. There's two special cases. Either everything works, and that's called an identity, or there's no solution, and that's called a contradiction. Okay, and again, those are your special cases of any types of equation, really. In this section, we're studying linear equations, which is when the variable is raised to the first power. But as we study other types of equations, it will be true there as well. If there is no solution, if you get just a false statement when you try to solve for your variable, you just get the variable drops out, and you have a false statement like 0 equals 7, where there's nothing that works for that. That's called a contradiction. And if you get something that's always true, like 6 equals 6, say the variables drop out and you just have a true statement left where everything would work if it's a true statement, that's called an identity. All right, so those are the special cases. Otherwise, we solve for x and get just the one solution in a linear equation. We should only one true answer. All right, 3. Which one of these is not a linear equation? So x's to the first. So you notice how this x, and this, all of these x's are not showing that they're raised to anything. So it's understood to be raised to the first power. That makes first degree understood linear equation. And so is this second one. Those are all x's to the first. Again, this is x to the first. So it is D, the one that's not like the others. X squared, we're going to study those later, but that's a quadratic equation. So this would be the answer to number 3. Which one is not linear? The one that has a squared term in it. All right, now we're going to solve some equations. So we'll start out with this one where we have x's on each side, so we need to get our x's to the same side. It's really up to you if you want to bring your x's to the left or the right. A lot of times you may have been trained to bring your x's to the left, and that's fine. You do not have to, though. I'll start out like that. I'm going to bring the 19x over to the left. When something crosses over this equal sign, it changes its sign. If it's a positive 19x on the left side, it'll be a minus 19x. 8 minus 19 is negative 11x, and then we'll take the negative 7 to the opposite side, making it a positive 7. You had a positive 15 plus 7, making 22, the equal sign down the middle. Then you divide by what's with your variable. You divide by the exact same sign, because what you're trying to do is create a 1x, and that's how you find x. You know, you're always looking for that x answer. So x is really 1x, positive 1x. So how do we make this positive 1? Negative 11 divided by negative 11 makes a positive 1x, or just x. Then what you do to one side, you do to the other side. So when we divide by the negative 11, 22 divided by negative 11 is negative 2. X is negative 2. We should check that answer back in the original problem. Is 8 times negative 2 minus 7 the same as 19 times 2 plus 15? Well, we can check that out. 8 times negative 2, that would be negative 16, minus 7, that's negative 23 on the left side. And the other side's the same. 19 times negative 2, let's see, that'd be negative 38. Negative 38 plus 15. Check the calculator if you like, but yeah, that's it. So the two sides are equivalent. That's how you check to make sure your answer is okay. All right, next up. So on this one, we're going to distribute the 8. 8 distributed makes that 32x. 8 times positive 6 is 48. Now on this side, don't make the mistake of thinking that 11 is to be distributed. It's what's directly multiplied in front of the parenthesis, which would be a negative 1 there. So you do need to distribute the negative 1, making negative 1x. Negative 1 times 7 is negative 7. Then combine your like terms, if there be any, on either side. So this side does not combine, so I'll just bring that down. On the right side, though, a positive 11 and a minus 7 would be 4. So we have 4 minus 1x, or 4 minus x. We need to get our variables to one side, so I'm going to bring this minus 1x over to the left side, making it a plus 1x for a total of 33 x's on the left. Then the positive 48 moved to the right side makes minus 48. 4 minus 48 is negative 44. Then the last step is always divide by what's in front of your variable. Since that is multiplied, the opposite is divide. 33 divided by 33 makes that 1x we're always looking for, regular x. What you do to one side, do to the other side. This doesn't come out perfectly, even as a whole number or as an integer, so we should reduce it as a fraction. Both of those divide by 11. 11 into 44 is 4, and 11 into 33 is 3. So do reduce any fractions to lowest terms. Usually in the answer, they prefer the more exact answer is the fraction answer. If you type this on your calculator, you're going to get a repeating decimal, and therefore you'd wind up rounding at some point, and the answer wouldn't be as precise. So this is preferred to leave it in fraction form, reduced fraction form. As you go through the course, you might keep mine. All right, next example, we're moving to fractions. All right. The first thing we always recommend when you have fractions in your equation is to get rid of the fractions. You want to clear your fractions by multiplying each side by an LCD. So the least common denominator for all these fractions, and you can think of this as being over 1, but your denominators are 10, 1, 5, and 5. And all those denominators will go into 5. So we call 5, into 10. Sorry about that. They all fit into 10. So 10 is the least common denominator, the least thing that all of these denominators fit into. It has to be at least as big as the biggest numbers, and that actually works because 5 goes into 10. So if you multiply both sides, we're keeping the balance, so it's allowed. And what happens when you multiply is multiplication distributes, just like we did on the last problem. So it distributes to every term in your equation, so it's applied throughout. So when we take 10 times 3/10, you can think of that as 10 over 1 times 3 over 10, and then the x's on that. The 10s are diagonal, so they just cancel out, leaving me just with a 3x. So, no fractions. Voila, no fractions. Then 10 times the negative 4, there's no fraction really to deal with there, so we can just multiply the 10 times the 4, and it's negative. Then 10 times 4/5. Let me write that out here. 10 over 1 times 4 over 5. And again, you can use your calculator if you prefer, but we can do a cancel out there diagonally. The 5 and the 10 reduce to a 2 and a 1, leaving 2 times 4 as 8. So that will be 8. No fraction. And then lastly, 3/5 times 10. Let's see, that's 3/5 times 10 over 1. And the thing we're doing here is crossing out the diagonals. So 5 goes into 10. You can reduce that. 5 into 10 leaves a 2. And then multiply what's left. So that's 6. So this strategy, we'll use it throughout the course. If you can clear the fractions, you'll make a much easier problem. So we always see a fraction, clear a fraction. Then proceed. 3 minus 40 is on the same side. Let's reduce that to negative 37x plus 8 equals 6. Move the 8 across. Negative 37x equals 6 minus 8, which is negative 2. 2 by negative 37 on each side to get 1x or x. Negative over negative makes that positive for one thing, and then 2 over 37, there's really nothing else to reduce there, no common multiples or no common factors, I want to say there. So 2 37ths for our answer. That one's going to be a little harder to check. I normally like for you to put that back in for x, and you could check it on your calculator fairly quick. 3/10 times fraction 2 37ths, and make sure it works out. Okay, let's do that again. 7. On number 7, it's almost the same. It's just regenerated out some values, but very similar. So we're multiplying by 10 again. And then we are going to, let's see, then we're going to multiply both sides by 10. 10 times 4/10 will be 4x. The 10s just cancel. 10 times negative 3 is negative 30, and there's an X on those. 10 times 6/5. Again, if you want me to show the work, it's 10 over 1 times 6 over 5. So the 5 is canceling into the 10 twice, then 2 times 6 for 12. So if you've picked the right LCD, the right thing to multiply each side by, this denominator should go into it evenly. So 5 should go into 10 evenly, which is 2, and then multiply by the top. That's where 12 comes in. So it's 5 into 10 is 2. You divide, and then you multiply what's left. And then do it again here. 5 into 10 is 2. 2 times 4 is 8. And then we have an easier equation to solve. Combine, these are on the same side, you know, so 4 minus 30, they're both x's. Then bring the 12 across. We've got negative 26x equals 8 minus 12, negative 4. Divide both sides by negative 26. Again, the like signs, negative or negative, makes it positive. And then 4 and 26 will reduce a little bit. You know, they're both even, so let's half each one. That'll make that a 2 and that a 13. So positive 2/13 for our final answer. Okay, I'm really aggravating you with these because I have another one. And I know I've asked this a lot because it's one that comes up a lot, and I notice that students can have trouble with it because of the fractions. They're just more trouble usually in general, so I wanted you to get a lot of practice with that. So again, with the LCD idea, we got 3, 3, 1, and 6. So the LCD is that 6. Everything will fit into 6. And then when we distribute that, these just totally cancel, leaving 5x. When we times the 6, we have to use that every time to distribute. So 6 times negative 2, and there's nothing down here to cancel it out. So it's the full 6 times 2. There's your 12. For this one, 3 cancels into the 6 2 times, then 2 times 8, 16. Or just check it on your calculator. Is 6 times 8/3, 16. Lastly, mine here makes that a 2 times 5 for 10. And through it from there, like we did the others. Make the 16 across the line. And I like to say when you're doing these, they are called exercises for a reason. When you're doing math problems, they call these the exercises. And it is really an exercise of your mind, an exercise of your procedures that you learn throughout the class. I know watching me do the problems is certainly an important step to attend the lecture and hear the concepts, but then what you really learn is in your own exercises whenever you start working your own problems. So it really is practice makes perfect. So I encourage you as you go throughout the course to keep that in mind, that every time you work a problem, you're getting a little better at these. And that's, if you already know this one, at some point you had to practice it to get that skill going. Okay, number 9. We're distributing this negative 7. So it's whatever's right directly in front of the parenthesis. Note you can't go 5 minus 7 because you're not allowed to add or subtract before you multiply because order of operations, you know. So we do have to distribute on these first if there's any distributive to do. Then we got a 3x and a minus 7x, which is negative 4x. A 5 and a minus 7 is negative 2. Then we need to get our variables to the same side. I'm going to take my variable to the right side just to mix it up a bit and show you that that's perfectly fine. A negative 4x brought to the right becomes positive 4x, which is 9x. Positive 5, positive 4x's. Bring the 3 to the left side then, which is minus 3. So we have a negative 2 and a negative 3. And we're using the addition properties, by the way. You're combining like terms when you do this procedure. So you're thinking negative 2 plus negative 3, combining those. So they're both negative for negative 5. Then you always divide by what's on your variable. So the 9 is what's divided out to make the positive x we're always looking for. And we got negative 5 ninths. Negative 5 ninths does not reduce any further than that. And then we could plug that back in for those x's and check it out on our calculator. Okay, I'm going to pause there and come back in the next video.